Hello everyone, my name is Alessandro Ronfini. I'm a partner at Demo Architects in New York City, and welcome to the Olive Passive House. About 3 years ago, my wife and I decided to buy a land in upstate New York. We're in Ulster County, and to design and build a house, a sustainable house for ourselves. As you can see, we're getting close to completion, and as you can see from my hair as well, we're still in the middle of the COVID-19 pandemic, so that slowed down a bit the construction of the house, but at the same time gave us the opportunity today to see behind the walls, behind the drywalls, and see the guts and the structure of this house. And while we're out here, let's talk a bit about the siting of the house. The house is sited overlooking a main focal point of the land, this pond. However, the pond sits east, and I needed to orient the house more towards the south for ideal solar exposure. To reconcile the desire to look straight at the pond while having the main volume of the house oriented correctly, I designed this wedge cutout that creates a secondary axis directing the view from the main living space to the pond. The house is a two-story structure with a slab-on-grade foundation poured over 10 inches of rigid insulation. This land has a very shallow bedrock, and the foundation is pinned directly onto it, making it extremely stable and surprisingly more expensive than I anticipated. The above-ground structure of the house was designed as a panelized system, designed and built with the help of Threshold Builders in Kingston, New York. I worked closely with them in order to achieve a system that would perform as required in order to achieve in this case, FEOS certification for this house, and at the same time achieve the design that I had in mind. As you can see behind me, the guts of the house are still exposed. We're getting ready for the blower door test and for the inspection. So you get a chance to see the structure of the house before it all gets covered with drywall. As you can see, the pattern of the mega panels that were used for the house is still visible. Each panel is made of a 2x4 stud structure. These studs are continuous from all the way from the base to the roof, and they support the weight of the roof itself and of course of the panels. On the outside of the 2x4 is 5/8 of an inch zipboard panels that are taped at all edges that creates the main air barrier for the house. On the outside of that, every 16 inches are TJIs running vertically, 16 inches deep, that are filled in between with dense packed cellulose insulation. To keep it in place and to protect it from the element, we have Intello Plus by Proclima on the outside that creates the main waterproofing barrier for the house. Outside of that, once again, there's furring strips that create a surface for the different sidings to attach to. On some elevation, this is the standing seam metal coming down on the facade. Some other elevation is that the Siberian larch. All the windows are taped at all edges with airtight tape, as you can see, and silicone where necessary, in order to make the house very airtight and of course waterproof. We're in the double height space, which is really the core of the house. That's the living room, dining room, and open kitchen. And the protagonist of the space in here is of course the landscape that comes through this big glass window exposed towards the southeast. This window is a stick-built curtain wall system made of wood frames. These have been over-designed deeper than necessary, not only to make it stable, but also to create some shade to the interior when the sun is pretty high in the sky. The system is of course triple glazed glass with pressure caps on the exterior, aluminum pressure caps, so it's protected, it's aluminum protected from the element on the exterior, and a nice warm and cozy wood on the interior of the house. This large extent of glass could create some overheating problems, especially in the summer, so we limit the amount of solar heat gain by introducing roll-up shades, exterior roll-up shades, which are hidden in the thickness of the fascia. We're on the second level of the house, in the lofted area upstairs. So this area, just like the main curtain wall, the stairs and the main entrance to the house, are oriented along the pond axis, so facing southeast, which makes this an ideal space where to work. We don't get a lot of direct sunlight, so no glare on your computer, and but at the same time a lot of natural light flooding in. While we're up here, we should also be looking at the roof of the house. So as you can see, the roof, well, the roof is different from the rest of the house in the sense that it's the only stick-built part of the system, of the envelope system. The roof sits on a ridge beam, which is supported by 3 steel columns going all the way down to the foundation. The ridge beam supports the rafters, which are TJI 12 inches deep, that are filled with dense packed cellulose insulation, as you can see in between on the interior side. Right outside of the TJI sits a sheeting material, zip board, 5/8 of an inch, also in this case, taped at all edges, which creates once again the main air barrier for the house. On top of that sits a 10-inch nail base foam insulation. Nail base is a 10 inches EPS foam with a 5/16 OSB board glued on top of that, which creates a thermal bridge-free surface to then attach the finish of the actual roof. On top of that, of this nail base membrane surface is the Solitex UM membrane. Solitex UM is a waterproofing membrane with a plastic mesh on top of that. This plastic mesh receives the roofing, the metal roofing, and allows for any water, any condensation water that might be on the underside of the metal to drain off the system so as to keep the roof constantly dry. As with every passive house, also in this case we're using forced air ventilation, so we're using a Zender Comfort Air for this purpose in this case. Because we're in a relatively cold environment in the winter, in order to compensate for that, we're actually also using a preheater that warms the supply air so that most of the house can be comfortable and warm at every time of the day during the winter, in addition to the heating system, the heat pump that is located upstairs. Thank you very much for listening and visiting my house with me. I hope you enjoyed it, and I hope there's going to be an opportunity soon to actually show you the house in person. Take care.